Hello once again and welcome to the third video in this series of my 8 kilowatt solar generator design. Today we are still on the design calculations, and today we are going to be sizing the inverter. So just a quick disclaimer there, you can pause the video and go through it. You can pause the video and take down my details if you want to get in touch. Yeah, you can get in touch with me if you have specific design needs that you want me to take a look at. Just get in touch with me. You can always reach me in the email displayed here. Right. We are going to be sizing our inverter, yeah, in 5 simple steps, and I've outlined all of them out, yeah. So the first step to sizing your inverter is actually to decide what the system voltage is going to be. Yeah, so there are several voltages you can choose from. You can choose a 48 volt system, you can choose a 24 volts or a 12 volts. Now the difference between them is that when it comes to sizing your batteries, yeah, if you choose a lower voltage, lower system voltage, when it comes to sizing your battery, you have higher number of batteries. So a 48 volt system, we use, or we have the lowest amount of battery that can power all your load. Say for example, if I chose a 12 volt system, yeah, I could, for example, use 10 batteries to carry a 10,000 watt hour load, yeah. And whereas if I use a 48 volt system, I could power what a 12 volt system can power. I could power maybe just 2 or 3 48 volts batteries, yeah. So, and one thing why your system voltage is very important is that when you choose this voltage, your inverter is going to have the same system voltage. So if I'm choosing a 48 volts system voltage, my inverter is going to be 48 volts, my battery is going to be 48 volts, and my solar panels are going to be rated as 48 volts solar panels as well. So if you choose one system voltage, all your 3 major equipment have to be that same voltage, yeah, for it to work very well. You could use a 12 volts battery for a 48 volt system, but you will connect it in such a way that it will multiply the voltage, yeah. And if you want to multiply the voltage, meaning that, for example, using the same example of the 10 batteries for a 12 volt system that I talked about, if I want to convert that 12 volts, if I want to convert it to a 48 volts system, yeah, then I'll have to connect all the batteries in series. What that means is that the positive terminal of one battery, you connect to the negative terminal of the other battery, and then you do them like that subsequently. When you do that, when you connect all your batteries in series, you multiply the voltages. And mind you, all 10 batteries, sorry, you're not going to connect all 10 batteries in series. Yeah, 48 volts is 4 12 volts. Yeah, we give you 48 volts. So 4 batteries you will connect in series. That will give you 24 volts. And the other 4, you connect another 4 batteries in series. That will give you, 48 volts. Yeah. And then when you connect those 2 48 volts in parallel, you then get a 48 volt system. Yeah. So there's a way, when we get to the stage of sizing the batteries, I'm going to explain to you all what I just said. Yeah. So very important that your system voltage, yeah, once you select your system voltage, it tells a lot. Everything has to be 48 volts. So your inverter has to be a 48 volts inverter. Your panels have to be rated at 48 volts, and also your batteries. When you connect them, you can connect them in series or parallel, but everything has to give a total voltage of 48 volts. Yeah, right. So the inverter must be the same system voltage, must be the same as the system voltage. That was what I just explained. So for my 8 kilowatt inverter voltage, I chose a 48 volts. Yeah. So that's the reason why we chose a 48 volts system. Now, the third part of the calculation is to calculate the continuous power of the inverter. Now, what is continuous power? Continuous power is, say for example, you've switched on your equipment and it's been like 15 minutes and above. Yeah, it's been running continuously. The power that it's pulling, yeah, from the inverter, that is your continuous power. And you get your continuous power by multiplying your, the total power for all your equipment that we calculated earlier on in the previous video. If you've not seen that video, go into that video how we did this load calculation. So you get that power, yeah, the wattage that the total wattage that we calculated, you multiply by 1.3. That will give us the continuous power of the inverter. What this means is that if everything is switched on and running, after some time, you get the 4,615 watts. That is our continuous power. Yeah. So whatever inverter we are selecting has to have a capacity that will cover this very well. Yeah. So that's our continuous power. Now, the next thing that is very, very important is the surge power, the surge or peak power of the inverter. This one is very, very, very important. Now, the way you calculate your surge power is you go to each of your equipment. If it is an air conditioner, if it is a refrigerator, yeah, anything that has compressors, anything that has electric motor, they are all going to have a surge power. What that means is this, yeah. A surge power is when you, for example, let's go mechanical now. When you have a mechanical system, a system of moving parts, yeah. Say for example, a pump, and this pump is just sitting idle, yeah, and it's ready. I'm talking about water pump now, and it's ready to pump, but it's just sitting idle, yeah. Newton's first law says that a body will remain in its present state of rest or uniform motion except it's acted upon by force. Yeah, so that force that causes it to move will always be higher. Yeah, because you need the force to overcome its potential energy. Yeah, and then once it starts to roll, to move, yeah, you need less force to keep it in motion. Yeah, so that is what the surge power is really about. The equipment is at rest and you're just starting it. So it will draw a higher amount of wattage of power to kickstart itself. Then once it's running smoothly, it has inertia. That inertia will keep that means that it will only require less force because inertia is already there. You have the centrifugal force already there. So that will keep it moving. If it's a rotating equipment, to keep it moving, So your surge power or your peak power is that starting power of your equipment. Now, for if you know the surge power, yeah, you can get the surge power for each equipment from your data sheet, the data sheet of your equipment, yeah. But if you don't have it, there's a rule of thumb. You multiply the normal power consumption or the normal wattage by 3. Yeah. So that is what I did here for most of the 3 refrigerators. I just multiplied their normal operating wattage by 3. So we are 300, 300, 300. And then I got the 1800 is the surge power of my inverter air conditioner that I got from the data sheet of the air conditioner. Yeah. And then the others, the 100, 400, 600, those ones, they don't have surge power. The 600 is for the 4 industrial fans. Yeah. They just rated a general power rating for them. They just gave a general power rating for them, which was between 100 and 150. So I chose the highest power consumption for it, and 4 of them 600, and then the other 100 I added to it, which was for the normal fan, no surge. And then the last one was the borehole. The borehole I used 3 times its operating wattage of 1100. So that is why we're having 3300. So that brings our total peak or surge power to 7200 watts. Yeah. So imagine all the equipment starting at the same time, that force that it uses to kickstart everything will be a maximum of 7,200 watts. Yeah. So once you get this right, you're not going to have any problem with your inverter sizing. So now we'll go on to the last and most important part, which is the selection of our inverter. Now we know that our peak load, yeah, or the surge power for all our load combined is 7,200 watts. So what you do is that you select the next higher inverter rating, yeah, and then the next higher inverter in the market is an 8,000 watt inverter. Now I have blotted out the brand for this inverter, but this is the inverter that I actually selected. I blotted out the brand simply because I'm not promoting any product with these videos. It's just purely educational. If it were to be a promotional video, yeah, I'll allow the brands to display, and I'll tell you, you know, in a very transparent manner that it is actually sponsored by that particular brand. Yeah. So in the, for this part, for all these videos, I'm not doing brand promotion. That is why I blotted those out. Yeah. So for my inverter sizing, yeah, in these 5 steps, I selected a 48 volt system. Again, the thinking behind that is so that I don't use too many pieces of batteries. Yeah. An 8,000 watt capacity hybrid inverter. I chose a hybrid inverter because for home use and for normal use, it's the most versatile that you can use. It can take grid power to charge the battery. It manages the charging of the battery. It does everything. It has inbuilt in it an MPPT. MPPT is your charge controller. Yeah, everything is just packed into one inverter. That is why I really like the hybrid inverter. It's a very, very smart inverter. Yeah, with it you're not going to go wrong. You're not going to have any problems. Yeah, so this is the thinking or the rationale behind the selection of my 8 kilowatt inverter. Yeah. And one other thing that I need to mention is your MPPT charge controller. For this particular one I selected, yeah, it has a 10,000 watt MPPT charge controller. What this means is that if you see the capacity of your charge controller is higher than the capacity of the inverter itself, yeah, this means that your inverter can take a lot more panel. It can take a lot more panels. A total total panel power that can exceed 8,000 watts. Yeah, so it's a very, very, very powerful specification to know. So always keep an eye on that one. The MPPT charge controller has to have a rating that is higher than the capacity of the inverter. Yeah, that brings us to the end of this video. I hope it has not been too long. If you have any questions, get in touch with me. I'm always available to answer all your questions. And like always, thanks for watching, and don't forget to subscribe, like, comment, share. Let's get this message across to a lot of people on how to build cheap solar power generators. Thank you very much.